Okay, so now we're going to find different forms of the equation of a line. So in grade 9, we had y equals mx plus b, and we had a different form, standard form, and both of those meant the same thing. So for the equation lines here, we're going to come up with different forms of those equations. We'll come up with general, vector, symmetric, scalar, parametric, all sorts of different types of forms. But remember that they always represent the same line. Okay? So in grade 9, we needed for y equals mx plus b, we needed two things. We needed a point and a slope. Well, the same thing still applies with this. For these ones, we're going to need a point, but instead of a slope, we're going to need
direction vector.
So since we need a point and a direction vector, we'll use the example, the last example. We'll use this one, and we'll find the equation line from here. So we've got 2 points. We've got the A point of -7, and we've got the B point 5, 4. Do you think it matters which point we need? No. So we'll just pick one of those. I'm going to pick the 5, 4 one just because it doesn't have any negatives in it, and we'll use the direction vector 7, 11. So off to the side here, I'll just remind us that we're dealing with our point. I know it's B, but we'll just say point, and we'll use 5, 4. And our direction vector is 7, 11. Okay, so the first part is general equation. And the general equation looks like this. Now, again, remember what an equation does. An equation describes how we get any point on the line. So if it was in y equals mx plus b, you would choose some x value, and the little formula that's there, you know, if it was like 2x plus 7, the little formula there would describe how you would get the corresponding y value. That's what all functions do, right? You pick an x, there's some sort of equation or whatever, you do something to that x, and it spits out a y, and it describes where you get that. This does the same thing, except it does it for every coordinate instead of just a single x or a y. So you'll see this xy here, it represents any point on this line. And you're saying any point on the line can be found by starting with this base point, 5, 4, and then moving through some scalar multiple of the direction vector. So if we were at 5, 4, you know, which is someplace around here, and we wanted to add just regular 7, 11, so k would be 1, okay? So if you're at 5, 4, and you add x equals 7 and add y equals 11, you know, you're going to go over like this much 7 and this much 11, you get to another point. And that describes another point on the line. And then I could keep doing this and add, you know, 7, 11, 7, 11, and you get all these points that describe the line. But remember, it can be any scalar multiple of that. So I went 7, 11 if k was 1, but I could have gone 14, 22, right? Which would be a scalar multiple. That would just skip this point. It would go 14 here and up 22, and it'd just find that point. Or you can find something smaller in between here, you know, like this one, or even the ones in the negative direction, right? Get this guy and this guy. So this equation describes all those possible x's because k can be anything. All you need is the direction to aim and then some point to start at, right? Like if we had another point over here, then that would be a completely different line, even if it had the same direction vector, because we're anchored someplace else. But in this one, we just need that point, 5, 4, and then the direction vector and move on. That's why it doesn't matter whether we use the 5, 4 or if we use the other point, the -2, -7, because it's just that point's on the line as well. So I'm just going to get rid of all this so that we can actually see what's going on. But that's the idea behind these equations. So there's the general equation. Okay, so our next one is called the vector equation. And you'll notice that each of these come from some of the ones before. And really, once we understand these, the hard part is just remembering which one is which. But we'll get used to that. So the vector equation actually comes from the general equation. So if you have xy equals 5, 4 plus k 7z, or 7, 11, excuse me, the vector equation does this. It brings the 5, 4 over to the left-hand side. So when you bring it over to the left-hand side, what operation do you think we have to do? Subtract, that's right. So we've got the x, and if we're going to xy, and if we subtract the 5, 4, we can actually do that to each component. We're going to do it to the x and the y. So the x goes x minus 5, and the y is going to go y minus 4. And it's like I just brought it to the left-hand side. And then the right-hand side is k 7, 11. This is just another version of the equation of the line. And it describes how if you take the point that you're on the line and subtract 5 and subtract 4, you'll always get either 7, 11 or some scalar multiple of 7, 11. All right, so that's the vector equation. I don't know why I wrote it up so high. There we go. Next, we have the symmetric equation. The symmetric equation says that if you have this one from the vector equation, your k is going to be the same for every point on that line. And so we can isolate k by itself by doing division. So you see it's k times 7, 11. So I'm actually going to divide the x by the 7 and the y by 11, and that's how we get the symmetric equation. So the symmetric equation looks like this. X minus 5 over 7, that's your x coordinate, and it is going to be the same as y minus 4 over 11. And it comes through division. This is probably one that I use quite a bit, the symmetric equation, and you'll see why in examples later on. One little note, the denominators in this case, the denominators is 7, 11, and those are the numbers of the direction vector, right? Those things are called direction numbers. So direction numbers are the numbers in the direction vector, and it tells you where to aim your vector. Okay, so there's symmetric. The next one is called scalar equation. Scalar equation is actually also known as standard form. So in grade 9 we called it standard form. Here we're calling the same thing, but it's called the scalar equation. So the scalar equation comes again from the one before it. So we're going to do the symmetric equation, but we're going to perform some of the operations. So you see how we've got divided by 11 here. I'm going to bring it up here and multiply. And divided by 7 here, and I'm going to bring it up and multiply up there. So if we actually do that operation, we take the 11 and multiply it by x minus 5. That's going to be equal to the 7, which goes up and multiplies by y minus 4. Actually do that multiplication. We got, what, 11x minus 55 equals 7y minus 28. And if you remember from way back in grade 9, standard form has all of the letters and numbers on one side and equal to 0. So we're going to leave the 11x here. We're going to bring the 7y over, and it becomes subtract 7y. The minus 55 is okay, but we're going to bring over the minus 28. So minus 28 becomes plus 28. And so it's minus 55 plus 28, and off the top of our head, it's minus 27 equals 0. And then that here is the standard form. So we've seen general equation, we've seen vector equation, we've seen symmetric equation, scalar equation, and the last one is parametric. Parametric actually doesn't come from the scalar or the symmetric, it comes all the way back from the general. So let's look at the general again. The general describes how every xy is found by taking the given point plus some scalar multiple of the direction vector. The parametric, instead of looking at it all together, looks at the x and the y coordinate separately. So it says you get the x coordinate by taking this x, which is 5, plus this x from the direction vector. So if we go down and actually write that out, it looks like this. X equals, and the point was, the x was 5, right? 5 plus 7k. The reason it's 7k is that 7 actually is getting multiplied by your k, isn't it? So the x coordinate is 5 plus 7k. So can someone tell me what the y coordinate of the parametric would be? Not the magnificent?
Y equals 4 plus 11k.
That's right. Was it 7? No, 4. Sorry. Matt distracted me with his magnificence. Y equals 4 plus 11k.